at this point, we're kind of digging into more of the actual like cloud-based resource issues surrounding infrastructure. So a lot of the other the first five anyway, I would say they're more on like the gaining access type of stage where we looked at password spraying, we talked about conditional access policies, we talked about files in SharePoint. That's more like the software as a service side for all of those. This is where we're going to start digging into some of the more interesting infrastructure issues. So issue number 6, Cleartext Creds in resource configs. When you deploy something like an EC2 instance or an Azure instance for that case, or a Lambda function, you can apply certain pieces of metadata to get passed down to those instances. And a very, very, very common place that we tend to find sensitive and secret data is in environment variables. And it's honestly due to how cloud-based resources leverage environment variables for carrying out tasks. So something that's very, very common is Lambda functions that have access keys and environment variables. I see it, like I would say good 75% of pen tests, where you will have API access, like I mentioned earlier, right? Like we have access keys, we're authenticating to the API, and simply having reader level permissions, right? Like I don't have to have the ability to actually access like an EC2 instance, like get onto an instance, or I don't have to have the ability to read the code necessarily of an environment variable. But if I have the ability to read configurations around Lambda functions, you can find environment variables. And this is something that is really interesting because it's like traditional context. Like if you have reader level permissions in any system, you generally don't have access to sensitive stuff. But environment variables and user data that's tied to EC2 instances tend to have sensitive data. So this is kind of what it looks like for a Lambda function, where via configuration of a Lambda function, you could use something like AWS list dash functions or AWS get dash Lambda get dash functions from the CLI to get information about certain Lambda functions. This is the output you would see. And in this case, environment variables are being passed to the function itself to actually carry out a task, right? So whatever this Lambda function is, it probably leverages these keys to authenticate and do something else, right? So, oftentimes things we'll find, things like I said, access keys in this case, Slack tokens end up there a lot, API credentials for web apps, SSH keys occasionally. It's a very important thing to look at, especially from the API perspective. Runbooks. So in Azure, runbooks are a way to automate pretty much anything you want to do in Azure from the infrastructure side. So with runbooks, they require what's called an automation account. So it's a service account of sorts that take a piece of code that you feed it and will carry out whatever task you want it to. And a lot of times we'll see runbooks for things like deploying resources, things for configuring resources. And in this case, I found on a couple of different engagements where runbooks contain like user creation scripts is a good example, where let's say you have a help desk that they deal with like 100 different user creations in a day, and instead of them manually doing it, they have a runbook. They're just like, oh, here's the username, and it goes and creates it. A lot of times those user creation scripts will contain like either like an initial password, or they will output the password to a log file. So looking at runbooks can be really interesting too. Issue number 7, insecure assume role policies. So this is a very, very, very specific one. And I'm going to give you like the 5-minute crash course on AWS permissions, but there's a lot more to cover. I'll just say that. But when it comes to AWS permissions, you have generally 3 different levels of accounts. So first off, you have your AWS account, high level. Like this is when you create an AWS account. You have the overarching like root account that you log into, and then you can create resources. You can do anything because you're the admin, right? Under that, organizations create IAM users, and identity and access management. That's a way of creating user accounts within AWS to carry out certain types of tasks that they need to carry out. So like let's say you have a dev who needs access to Lambda functions or S3, and then you can apply policies to those users based off of that one user account. And then lower than that, you have temporary security credentials. So temporary security credentials get generated on a very temporary case-by-case basis. And we'll talk more about those in just a second. But when it comes to policies, like I said, I'm not going to dive into it too deep, but you can apply an action, an effect, and what type of resource they're applied to. So actually, it's a typical like allowed deny type of effect. What action they're allowed to do. So can they just get resources? Can they list resources? Can they do anything against certain resources? And then ultimately, what resources are they applied to? When it comes to temporary security credentials, they tend to show up in a few different places. So I'm going to talk about the metadata service here in a second. But back to the insecure assume role policy topic of this particular section, assume role policies are a way to provide access to something that a user doesn't have access to by giving them the ability to assume a role. So what this means is like, let's use the diagram to walk through this. Let's say Joe needs access to DynamoDB. Now, Joe does not necessarily have a policy applied to him or to DynamoDB directly that gives him access to it. But what he does have is he has what's called an assume role policy, which gives him temporary access to DynamoDB. So Joe can authenticate with his keys, and he can call what is known as the STS, so the security token service, assume role policy. And what happens is if he is a member of that assume role policy, he is granted temporary keys. So it's a way of basically creating temporary access for him to access this resource. Now, leveraging those temporary keys, he can then go and authenticate to DynamoDB. Now, to kind of expand on this, right? So at a high level, you can do this exact same thing, but for pretty much anybody, and including outside of your own account. So you could say, I want, anybody in my organization can be an admin if they want to be by assuming this role. Like you can create an assume role policy that does that. Or you can say, you know what, I have an external auditor. Like let's say Black Hills is going to do a pen test, and instead of creating an IAM user account for them in my actual AWS tenant, I'm going to create an assume role policy, and I'm going to apply it to Black Hills' external AWS account. And so me as a pen tester, I can call that assume role policy as an external tenant or external account and get temporary security credentials to gain access to the organization's account. It's a super common way to provide what I would consider cross-tenant access, right? So in Azure, you have guest users within a tenant. Same thing in AWS. You can have assume role policies that allow you to assume across roles. Now, that being said, when it comes to insecure assume role policies, you can also be overly permissive with how you apply these policies. So in this case, this is an example from an assessment I did where the policy itself allows access to the Lambda service, okay? However, if you look at the AWS parameter right in the middle, you see star. So principal AWS star. So that literally means that any AWS account can assume this policy. And so even from outside, right? So anybody in the world could assume this policy and gain access to Lambda within this particular organization's environment. So this is something that I see come up occasionally where the assume role policies are just overly permissive. Number 8, privilege escalation via metadata service. The instance metadata service is an interesting, it's just an interesting thing that exists that if you didn't know about it prior to today, I apologize for the research you might be diving into after this presentation. Because I sure as heck was like, what is this? Like, I can't believe that this exists when I first learned about it. So whenever the concept of cloud environment was conceived, they were like, you know what would be a good idea? Why don't we put a web server on every single VM? And that way we can tell those VMs what they're supposed to do or who they are and what network they live in. And so this is where the metadata service was born. Every single virtual machine instance, so EC2 instance, Azure instances, they have a non-routable web server that is running on a local IP of 169.254.169.254. And so this is something that like when I was like, wait, there's a web service running on every single VM, like why? And so it gets deeper because this is also a way that you can provide credentials two virtual machines. Let's say that you had a virtual machine that needed to access a storage bucket, right? Instead of hard coding creds to the disk in like a file, you could have this instance metadata service apply a policy which grants them temporary access. Again, back to the temporary security credentials. So what this means is that as attackers, if a policy has been applied to that virtual machine and we can query it, either via, we've compromised the server and we can query it locally, or if we can query it through other vulnerabilities such as SSRF, we might be able to obtain new sets of credentials. So server-side request forgery is a common one that comes up when it comes to metadata service. And the reason is because server-side request forgery is a vulnerability that allows remote attackers to cause a web server to send a request on behalf of that web server. So if the web server is running on an EC2 instance, or if the web server is running on an Azure VM, and you are able to find SSRF and you're able to send a request on behalf of that server to that local metadata service, you may be able to have it actually pull role policy credentials. One example of it is on AWS. The endpoint is 169.254.169.254/latest/metadata/data/IAM/security-credentials, and then the IAM role name. So if you were to hit that IAM role name and there's a role policy applied to it, this would spit out a set of temporary security credentials. And in a lot of cases, those credentials give you access to other stuff, right? Like it's the whole point of it. This actually, this is one of the ways that Capital One got hacked. So the attacker exploited SRF on an EC2 server. They accessed the metadata URL, got IAM access keys, and then leveraging those access keys, they were actually able to access a private S3 bucket that had sensitive data, things like credit card numbers, SSNs, you name it. Number 9, unpatched and or exploitable resources. This is your traditional catch-all for things that are not patched, right? Like so here's where it gets a little different when it comes to cloud, right? And this is what I try to speak to when it comes to patching systems, when it comes to cloud infrastructure, is in most scenarios, IT teams, security teams are pretty decent about doing asset inventory internally. Like they know in a lot of cases, here's all our servers, here's all our Windows servers on-prem, and we know we've got to patch them on this life cycle. What happens is with cloud-based services, permissions to deploy resources tends to not be watched as much. So what I mean by that is, a lot of times you'll have a developer group and you'll say, hey, devs, you know what? You can deploy as much as you want in the lab environment because that's where you're going to, be operating. You're going to be building cool stuff. So what'll happen is they will, start deploying resources, but they're not under the same asset management, not under the same patching lifecycle. And so things get out of date and thus vulnerabilities show up. So on top of just the patching issues, you have to worry about public exposure of these resources too. So things like insecure web apps, things like, Lambda functions or serverless functions in general exposed externally, things like database services that have weak creds, because that's another thing that comes up with cloud resources, is the ability to make things public is so much easier than it is in a traditional on-prem world. And it's because of just that freedom to deploy resources, right? And so what this means though is that things get exposed publicly, and during compromise, you have leakage of sensitive data, access keys, and ultimately underlying server infrastructure. So here's the thing. When it comes to public resources, you can attempt to identify a lot of this stuff externally, right? Like you can do DNS brute forcing, you can do a lot of recon around what you see publicly, but you're not going to find everything. And what I've seen, and honestly in my experience, is that after authenticating to an account, so let's say that you get reader level permissions, let's say that you find a key in a repo somewhere, right? And you authenticate, or maybe you're doing a cloud pen test and you've been given reader level permissions. The second you actually are able to go authenticate and start to read configurations, you will find all of the load balancers, all of the EC2 instances, all of the databases. And so what I did is I started building out these cheat sheets of a lot of things I'm running on Pentest to find a lot of this stuff. And what I would do is I'd go enumerate everything. So what I tend to do is I literally try to enumerate every DNS name, every IP address I see, and then scan it from the outside, right? And what tends to happen is you'll find stuff that probably shouldn't be exposed publicly. I'll leave it at that. Issue number 10, overprivileged accounts. So just like any authentication system, you have to worry about giving too many permissions to people. So how would privilege escalation in the cloud look, right? Like, how does it look? It's not much different than it is internally, to be honest. Here's some, I guess, like high-level description around how privilege escalation looks in Azure. So in Azure, you have the ability to create what are called subscriptions. And subscriptions are basically ways to group and silo off different sets of resources. Now, you can apply permissions to subscriptions. You can apply permissions lower than that at resource groups and resources under that as well. So you can apply back to the, what was third or fourth slide, where you have resource-based versus identity-based policies. This is where those resource-based policies come into play, right? Where policies are being applied directly to resources or subscriptions. In addition to that, you also have built-in roles that provide a level of access control that can give certain users certain levels of access. There's a couple hundred default ones as well. So in this case, I listed 4 here because these are some of the more common ones. Owner can do pretty much anything on a subscription. Contributor can do everything an owner can do, except they can't change permissions. You can have readers, user access administrators. The idea here is that you have lots of different roles, lots of different permissions that are built in by default. One big thing that organizations have to worry about too, in addition to the uses they create, are service principals. And with service principals, this is one thing that sneaks up on a lot of organizations, because by default, the day you go sign up for a Microsoft account, I think this number might actually be up to like 300 now. I need to go check. But as of like last year, 200 default service principals get generated in a Microsoft 365 tenant. So the day you sign up, you have 200 service principals, and every single one of them have different permissions applied to them. So, certain service principals have more administrative functionality. They have deeper levels of read level access or ownership over certain resources, the ability to do things. So one example of privilege escalation is around how application administrators can change passwords or add new secrets for applications like service principals, but application administrators cannot create users. However, if you were to change the password or add a secret for a service principal, that would then allow you to leverage other permissions that the application administrator didn't have. And so Azurehound, one of my favorite tools for finding these. So running Azurehound, it's just like running Bloodhound internally on an Azure Active Directory domain. But in the cloud, you can run Azurehound now to collect all the Azure data, which is beautiful. So you can actually collect all of the service principals, all the permissions tied to them, all the users groups, and do the exact same types of path analysis as you would internally, but in the cloud. And in this case, it's a very, very simple path where I have Janet Johnson on the left. Janet's an application administrator. Janet has the ability to add a secret to a service principal called client ID-harvester. And the client ID harvester is a member of the global admins. So in this case, Janet's not a global admin. However, she has the ability to add a secret to a global admin, therefore escalates privileges. That's all 10. I've got a couple minutes here to just kind of throw a couple resources at you real quick. I've got my Cloud Pentest cheat sheets in there. Road Tools, amazing tool. PowerShell and Microburst, amazing PowerShell tools for interacting with Azure. If you're looking at scanning environments for security issues, Prowler, Azurehound Scout Suite, they're all decent tools for at least getting that kind of like best practice kind of look. And then, just some key takeaways for you guys. Recon is still, key for us understanding cloud usage. Like from the outside, being able to do recon is great, but also from the authenticated APIs that we leverage to do recon as well, can show you a lot. The cloud attack surface enables us multiple ways to get access to an account. As you saw today, like top 10 issues, configuration of cloud resources is a Wild West. It really, really is. It changes every day. Like I update my class pretty often. And every time I teach it, I have to go through the labs and update stuff because things tend to break. And it's just because the cloud's moving so fast. And then to leave you with some key methods for gaining a foothold, look at those repositories for secrets, public repositories. Look for finding access via password attacks, phishing, remote code execution in some cases. And ultimately, just do situational awareness. That'll help drive your decisions post-compromise. And right on the dot, 2 p.m., nailed it. Jason and Deb. I didn't go over this time.
No, good job.
You were talking so fast at the end.
Yeah,
I know. I'm so sorry.
It's perfect. It was great. I was just trying to finish.
Here's what we're going to do. We're going to finish the webcast and say thank you so much for joining us. If you need to leave, we know you might have somewhere to go. So we're going to stick around, maybe ask Beau 1 or 2 questions for like 4 or 5 minutes. We're going to talk about the cloud security expansion deck for backdoors and breaches, which is available now on play.backdoorsandbreaches.com. So we're going to do the whole thank you so much for joining us for this Black Hills Information Security webcast. Beau, do you have any final words?
Go secure your stuff. That's
secure your stuff. All right, so we're gonna. All right, the webcast is over. But well done.
Thanks. Thank you. It's pretty fresh because I think I told you a little bit before before the webcast that I've spent like a lot of time over the last couple of weeks revamping my class. Because I wanted to freshen it up. I've been updating it like here and there for like just little stuff. But I took an entire day and just like delete. and it's just, and honestly what it is because I think there's more relevant stuff, like newer stuff, that I think was more important to add in. So yeah, I'm actually super excited to teach it in June, and then ultimately a Deadwood too.
Yeah. I mean, you said it, it's changing rapidly. So thanks for updating your class. I know all the people who are on-demand training and subscribe to it are appreciative of that.
Yeah, they get the updates. Yep, the on-demand students get the updates.
Yeah. Question for you. Have you found any tools disappearing by McAfee Defender Sentinel?
Disappearing?
Yeah.
No.
So I take it like maybe that means like the AV is like catching it. that's how I would interpret that. Yeah. So I see. I mean, even my own tools tend to get caught with Defender even. So yeah, I mean, it's something that honestly just like adding a comment in most cases gets around a lot of the AVs endpoint protections, especially with just like simple PowerShell scripts.
Okay. Are you here? Let me find it again. Are you going to do an AWS Pentest Top 10 Issues?
So, this is, I mean, it's some like, so this specific talk incorporated a lot of AWS stuff. I could do that. I mean, so I did the securing AWS webcast, like half a year ago.
Yeah.
And I think, you could probably go watch that one and get pretty much exactly what I would say in the top 10 anyway.
MFA sweep hasn't been updated since November 2022. I mean, that's not too long ago. Is development still active?
Yeah, I mean, it's so anytime that there are new portals, I add them in. So if there's something that like if you run across any authentication portal on Azure that isn't in there, definitely let me know and I'll try to add it in. But yeah, I mean, as of now, last few times I've used it, it's worked. So that's my I would say like my mantra with tools is I'm not I don't subscribe myself to update my tools often. And to be honest, it's because like I when I need them, then I update them. It's not like, I mean, PRs are great. Like, and if you fix something, please let me know, and I'll add it in. But yeah, and in most cases, if it's not broken, then I don't go about adding anything else.
I was at a conference the other day, and I was talking to a person, an aspiring pen tester, and I was talking about some of the tools that you've developed, Mike's developed, other people have developed, and it's listed on the cards, right? It's listed on the Backdoors and Breaches cards, and he's like, "Oh, I just learned that tool for Hack the Box. Like that was
sweet.
The tool that was recommended."
What? That's awesome.
Yeah.
Cool.
Is there any cloud provider that's more inherently more secure than others, or are they all vulnerable in their own way?
That's a good question. So I would say they're different. Not necessarily that they're more vulnerable or one's better than the other. That being said, I would say the use cases for how organizations are leveraging cloud environments is probably more important when you look at that question, because what we tend to see is organizations leveraging Azure and Microsoft 365 for the software as a service side, right? And we typically don't see that same level of usage on GCP, on the same level of usage as AWS, because there isn't really a SaaS side to AWS. So the inherent vulnerabilities, I would say, tend to show up more on the Azure side, purely because that's what we end up attacking more than anything else. And it's because organizations use Microsoft 365 for email and Teams and stuff. And so when we're doing red teams, we're doing cloud assessments, like we're targeting their users. And like that, just as a result of that, means we're getting in through Azure attacks. So
I think that's a great segue into the cloud security deck. So we have this game called Backdoors and Breaches, helps you learn cybersecurity and conduct tabletop exercises. And we worked with Beau for a long time developing the cloud security. And it's not necessarily provider focused, it's overall focused. Every once in a while, we'll talk about a specific provider. And once again, you can choose the cards that you want when you create your own scenario inside Backdoors and Breaches. And if you go to play.backdoorsandbreaches.com, you can actually find the security, the cloud security deck now, and you can start using it now. And over time, we'll start working on different scenarios for it, and we'll add those to GitHub. And then, Beau, you and I are going to do a webcast in September, specifically on the cloud security expansion deck. We want people to have it. We want people to be using it. We want people to actually have it in their hands if they want to before we do the webcast. All right, Beau, anything else before we wrap up?
No. Thanks everyone for hanging out. Happy to get to talk security stuff. So appreciate it.
And if you do get the on-demand version of Beau's class now, it will be updated in the future. So you would most likely get both versions. So.
Yep.
All right, everybody. Thank you so much for joining us. We'll see you next time.
Thanks everyone.
Thanks for watching. Achieve your next level of skills with training courses at antisyphontraining.com.